Question 8, part 2. Question 8, part 2. And just to remind ourselves that the object starts off at 10i and 35j. Okay, so it starts at 10i and 35j meters per second, right? So in part 2, what we're actually asked is the time till its velocity is 10i, and so time at 10i and 10.5j, 10i and 10.5j. So that's what we're actually asked for. What is the time when it's at this? So what does that mean? Well, imagine, always think about when it starts. It starts off going up at 35j, and then it has this 10 there all the time, okay? Now it goes up and it comes around like so. Okay, so it starts at 35 up and 10 horizontally. Now at some point, every point it'll be going 10 horizontally, so that stays the same. But at some point it will have a velocity of only 10.5 going up, and it will still be obviously going 10 that way. That's fine. So we want to know what is the time at that point. Okay, so if we just look at things vertically, we can see that it has initial velocity 35. When it has a velocity of 10.5, what's the time? That's what we're asking ourselves. So U, V, A, S, and T. So Y, 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 and Y. So equals. So what we'd like to know is if the initial velocity was 35, final velocity is 10.5, acceleration is minus 9.8, distance not interested in. The time, what is the time when the velocity becomes 10.5 if it's decelerating at this? So again, it's a V equals U plus AT, which is handy because that's the easiest of the equations, and this is 10.5 equals 35 minus 9.8 times t, which we're looking for. So 10.5 minus 35 is 24.7, so that would be 10.5 minus 35 divided by 9.8 actually equals t. So the 10.5 minus 9.8 leaves us with 24.5 divided by 9.8 equals t, so that means t equals 2.5 seconds. So that's the time here. The time to get to there would be 2.5 seconds.